In number 4, we're finding the domain of a function. Now, let's just very loosely think of the domain as all possible x values. All right, so what we mean by that in this function, what x values can we substitute in and yield a corresponding f of x value or a corresponding y value? Like if we substitute in 0 for x, we get the y value minus 4 over minus 9, or 4/9. So pretty much whatever we substitute in for x is going to yield an f of x value, except for a couple of values. Now, the exceptions occur with x values that make the denominator 0, because we can't divide by 0. So if we're finding the domain of a rational function, a function that's a fraction, then we eliminate the zeros of the denominator, or the x values that make the denominator 0. All right, so let's just, in order to find those x values that make the denominator 0, we factor the denominator. So in other words, we're finding what we call zeros of the denominator, or you can also call them roots of the denominator. I'd rather call them zeros of the denominator. All right, that's x values that make the denominator 0. So just factor x squared minus 9x plus 3x minus 3, and we see that there are two x values that are zeros of the denominator. The two x values are x equal minus 3, because that would make the first factor equal to 0, and x equal 3 would cause the second factor to be equal to 0. So these are the zeros of the denominator, and we want to eliminate them from the domain. So our domain, which is very often called x, like an uppercase x. Okay, that's another way of writing the domain. So we can say that our domain is equal to all x values except 3 and minus 3. And here's just a easy way of writing that. In number 5, we are finding the domain of this function that contains a radical. So this isn't a rational function. Here we have a different concern. We want to make sure that we don't substitute in any x values that will make the radicand, the expression 2 minus 3x, negative, because the square root of a negative number is not a real number. All right, so we want to make sure that 2 minus 3x is always greater than or equal to 0. 0 is fine. The square root of 0 is equal to 0. That is a real number. Okay, so in other words, we want to make sure that 2 minus 3x is greater than or equal to 0. And those x values will be in the domain. All right, so subtract 2 from both sides. We are solving this inequality over here. Now divide by minus 3, and remember that when we divide an inequality by a negative, the direction of the symbol is reversed. All right, so here we have x less than or equal to 2/3. And that's our domain. We can just write it like this, or if you want, we could use that capital X notation and say that this is what the domain is equal to. All values x that are less than or equal to 2/3. Now the function in number 6 is both a fraction and it contains a square root. So we want to make sure that the denominator is not equal to 0, and we also want to make sure that the radicand, whatever's underneath the square root, is never negative. Okay, so combining both, instead of writing x minus 5 greater than or equal to 0, this time we write x minus 5 strictly greater than 0. All right, and that's because this appears in the denominator, so we don't want the denominator to equal to 0. Okay, and so adding 5 to both sides, we have x greater than 5, and that's our domain. In number 7, we have what is called a piecewise defined function. That is a function that's defined in two pieces, two different lines, one piece for x values that are less than 1 and the other for x values that are greater than or equal to 1. And now we just want to find three values of our function, f of minus 3, f of 1, and f of 10. Now we're going to use either the top line or the bottom line to find these values. Which line we use depends on where our x value is. Okay, so to start with, we want to find f of minus 3. Well, where is minus 3? Minus 3 is in this category. Minus 3 is less than 1. So use the top line. And we substitute into x minus 3. So f of minus 3 is minus 3, which is negative 6. Okay, now we want to find f of 1. Now, which category is 1 in? Well, it's in the second category. The second category covers x values that are greater than or equal to 1. The equal to 1, this one is equal to 1. This one's just less than 1. The equal to 1 is why 1 fits into the second category. All right, so we're just going to use the second line now, substituting 1 in. And we get 6. And finally, we're evaluating the function at x equal 10. Now, which category is 10 in? Well, 10 is larger than 1, greater than or equal to 1. So again, use the second line. And substitute in, and we get 24. In number 8, we have two functions, f and g, and we're going to form composite functions. All right, that's f of g of x and g of f of x, basically substituting one function into the other. So let's start with f of g of x. Well, here, this is what g of x is equal to. G of x is x squared minus 5. So let's put that in. Now let's write our function f. F is 2x plus 3, and we'll put a blank set of parentheses instead of x. Now whatever we have in here, we put in here. Okay, so put the x squared minus 5 in the blank set of parentheses. And that's it. That's our composite function. Now maybe we want to simplify a little bit by multiplying through by this 2. Okay, so that would give us 2x squared minus 10 plus 3. And we can combine these two like terms. And we have 2x squared minus 7. All right, we're going to do the other composite as well, g of f of x, and this time we're going to substitute f into g. So what is f of x? F of x is 2x plus 3. So just put that in there. And now let's write g using a blank set of parentheses instead of x squared. All right, now put the 2x plus 3 into this set of parentheses as well. Okay, that's it. That's the composite. Now if we want to maybe open up parentheses, we can do that. We can square out 2x plus 3. Okay, that's 2x plus 3 times 2x plus 3. Okay, if you want, you can just write that out on top just to help with the multiplication. I'm just going to write it small just to help with the FOIL. Okay, so 2x times 2x, that's 4x squared. And then we have 3 times 2x, that's 6x, and another 6x, that's plus 12x. And 3 times 3 is 9. Minus 5, so we have these two like terms. 9 minus 5, so we get 4x squared plus 12x minus 4. 4x squared plus 12x minus 4. Sorry, 9 minus 5, that's plus 4 over here. 9 minus 5 plus 4. Okay. So that's it.